This is grade 11 economics revision lesson provided by the Ministry of Education. In the previous lesson, we saw the theory of consumer behavior, more specifically the cardinal and the ordinal utility theories. Today we are going to revise Unit 4, which is about theory of production and cost. That means we are going to see three major lessons or theories under this unit called theory of production, theory of cost, and the link between production and cost. Let's start with theory of production. Production is the process of converting inputs into outputs. It is the process of converting economic resources into more useful forms. Suppose the farmer produces the output weights by employing farm inputs such as land, oxen, fertilizer, seed, and labor. From this example, these land, labor, oxen, fertilizers, and the likes are considered as an input, but the output is the weight. Now let's see some of the terms used to describe the theory of production. First, outputs is the final goods and service, which is the outcome of the production process. In our example, if the farmer produces weights using the inputs land, labor, capital, and the likes, the output is the weights. But the inputs are those resources which can be used for the production of the outputs. In our example, if the farmer employs land, labor, fertilizer, and seed to produce the output weight, hence these resources, land, labor, and fertilizer, are considered as inputs. These inputs are further categorized into two called fixed input and variable inputs. Fixed inputs are those inputs whose quantities do not vary at the level of output vary. That means even though there is an increase in the level of output, if there is no change in the inputs used in production, such input is categorized under fixed input. For example, land and building are usually considered as fixed inputs. But the variable inputs are those inputs that directly varies with the level of output. That means inputs that increases at the level of output increases, and inputs that decreases at the level of output decreases are called variable inputs. Most of the time, labor is considered as a variable input. Now let's illustrate these terms using the following farm model. Under the production function with one variable input, here the farmer produces weights, and this is land, oxen. The farmer produces weights using this 2 hectares of land. So the total product of 2 land is 0 here, and the total product of 2 hectares of land is 5. Again, the farmer also produces 11 quintal from 2 hectares of land. The farmer again produces 18 quintal from 2 hectares of land, 24 quintal from 2 hectares of land, 27 quintal from 2 hectares of land, 27 quintals from 2 hectares of land, and 25 quintals of weight from 2 hectares of land. In this case, even though there is a change in the output produced, there is no change in the inputs employed. Hence, land is considered as fixed input. But when we see the amount of labor employed, the total product of 0 labor is 0, and 1 labor is 5 quintal, 2 labor is 11, 3 labor is 18, 4 labor is 24, 5 labor is 27, 6 labor is 27, and the total product of 7 labor is 25. Hence, with the change in the amount of labor employed, there is a change in the total product. So labor directly varies as the level of output varies. Hence, we can consider labor as the variable input. Now let's come back to some of the terms used to describe production. There are two production periods called short run and long run. Short run is a production period in which the quantity of at least one of the inputs used in production remains fixed. That means the firm employs at least one fixed input. But in the long run, all the inputs used in production are variable. Remember here, the time horizon is not used to distinguish whether the production period is short run or long run. A production that lasts for 100 years might be in the short run, or a production that lasts only for 3 months might enter into the long run. Because if all the inputs used in production are variable, then the production is said to be in the long run. But if at least the quantity of one of the inputs used remain fixed, then it is considered as short run. Production function shows the maximum possible output that can be produced from a given combinations of inputs. It also describes the technical relationships between the various amounts of inputs used in production and the resulting output. So the output is a function of the inputs: land, labor, fertilizer, seeds, and the likes. Now, under the theory of production, we are going to see different production functions called production function with one variable input, production function with two variable inputs, and returns to scale. Let's start with the production function with one variable input. Assume that the farmer employs a fixed amount of fertilizer, seeds, and the likes. Again, the farmer produces wheat on 2 hectares using 2 oxen. So from this farm model, we can see that the farmer employs only one variable input, which is labor. So by increasing the amount of labor employed and by decreasing the amount of labor employed, the farmer can increase his output, the amount of wheat produced. This is the model. The farmer produces the output wheat on 2 hectares of land using 2 oxen. So the amount of land in oxen is not changing whether the farmer produces more of the wheat and less of the wheat. Hence, oxen and land are fixed inputs. But the farmer increases or decreases the amount of wheat production by increasing and decreasing the amount of labor employed. Hence, labor is considered as the variable input. Now, let's see the average product of the variable input labor and the marginal product of the variable input labor. Mathematically, the average product of the variable input labor is calculated by dividing the total product for the amount of the variable input labor employed. So the amount of total product from 0 unit is 0. This means without employment of the variable input, there is no output. Even though we do have the land, oxen, fertilizer, and seed, without labor, we cannot produce any amount of wheat. So in the short run, the total product of 0 units of a commodity is always 0. And the total product of one labor is 5 quintal. That means it is calculated by dividing 5 for 1. This indicates that the average product of one variable input labor, one labor, is 5 quintal. This indicates that one labor is producing 5 quintal on average. When we see the second one, the average product of 2 labor is 11 quintal. That means it is calculated by dividing 11 for 2, and then it will give us 5.5, and this tells us if two farmers produces 11 quintal, then one farmer is producing 5.5 quintal on average. Similarly, if 3 laborers produce 18 quintal, then the average product of one labor is 6, and if 4 labor produces 24 quintal, then one labor produces 6 quintal on average, and if 5 labors produce 27 quintal, then one labor produces 5.4 quintal on average, and if 6 labor produces 27 quintal, then one labor produces 4.5 quintal on average, and finally if 7 labor produces 25 quintal, then one labor produces 3.58 quintal on average. This is the way of calculating the average product of the variable input labor. Now let's see the marginal product. Marginal product is the additional output produced from additional implement of the variable input labor. Mathematically, the marginal product of the variable input labor is calculated by dividing the change in the total product divided by the change in the variable input labor. For example, if 0 labor produces 0 quintal, and if we get 5 quintal from one labor, then the additional output produced from additional implement of the variable input labor is 5. Mathematically, the marginal product is calculated by dividing change in TP, which is TP final minus TP initial, divided by the variable input labor final minus the variable input labor initial, which is change in labor. So let's take this 0 as labor initial and this one as labor final. Let's take this 0 as TP initial and this 5 as TP final, and then when we substitute this information on this formula, then the value of TP final is 5 minus TP initial is 0, divided by the value of labor final is 1 minus labor initial is 0. This is 5 over 1, which is 5. So this indicates that as we increases production, as we increases the implement of the variable input labor from 0 to 1, if the total product increase from 0 to 5, then the additional output produced from additional implement of the variable input labor is 5. Similarly, if one labor produces 5 quintal of weight and 2 labor produces 11 quintal of weight, then the additional output that we got from additional implement of the variable input labor is 6 quintal. Mathematically, it is calculated by dividing 11 minus 5 for 2 minus 1, and this will give you 6. Again, if 2 labor produces 11 quintal and 3 labor produces 18 quintal, the additional output produced from one variable input labor is 7 quintal. And again, if 3 labors produce 18 quintal and 4 labor produces 24 quintal, then the additional output produced from the additional implement of the variable input labor is 6 quintal. That is mathematically calculated by dividing 24 minus 18 for 4 minus 3, which is 6 quintal. Again, if 4 labor produces 24 quintal and 5 labor produces 27 quintal, the additional output produced from additional implement of the variable input labor is 3 quintal. Mathematically, it is calculated by dividing 27 minus 24 for 5 minus 4. Again, if 5 labor produces 27 quintal and 6 labor produces 27 quintal, then the additional output produced from additional implement of the variable input labor is 0. That means it is calculated by dividing 27 minus 27 for 6 minus 5. In this case, there is no additional output produced from additional implement of the variable input labor. Finally, if 6 labor produces 27 quintal and 7 labor produces 25 quintal, the additional output produced from additional implement of the variable input labor is negative 2 quintal. That means with additional implement of the variable input labor, there is a negative output produced from the given combinations of inputs. This is the total product. Total product is the total output produced from the given variable inputs, and the marginal product is the additional output produced from additional implement of the variable inputs labor. Mathematically, we saw the way of calculating the marginal product of the variable input labor based on the table that we saw on the farm model. This is the way of calculating the marginal product of the variable input labor. The average products is the total products per unit of the variable input labor produced, and mathematically it is calculated by dividing total product for the variable input labor. This is the way of calculating the average product of the variable input labor. Accordingly, the average product of the first labor is 5 quintal. The average product of the second labor is 5.5 quintal. The average product of the third labor is 6 quintal. The average product of the fourth labor is 6 quintal. The average product of the fifth labor is 5.4 quintal. The average product of the seventh labor is 3.5 quintal. Now let's see the graphical representation of production. This is the total products. While you are going to plot the total product curve, just represent all the values of total products in the y-axis and all the values of the variable input labor in the x. And this is total product curve, which is N-shaped curve. Again, in order to plot the average product of the variable input labor, just represent all the values of average products in the y-axis and all the values of the variable input labor in the x. Similarly, in order to plot the marginal product of the variable input labor, just represent all the values of marginal products in the y and all the values of the variable input labor in the x. Now, from this curve, we can point out some relationships between total products and average products and marginal products. First of all, let's see the relationships between the total product of the variable input labor and the marginal product of the variable input labor. Now, starting from this point to this point, the marginal product curve is increasing. That means MEP is increasing, means the additional output that we get from additional employment of the variable input labor is increasing. Hence, whenever the marginal product increases, the total product curve is increasing. But the total product curve increases at an increasing rate because the additional output will provide more outputs. So whenever MEP increases, TP increases at an increasing rate. This is the first relationship between total products and marginal products. Starting from this point to this point, the marginal product of the variable input labor is declining, but it is positive. Whenever MEP decreases but positive, the total product curve is again increasing. The TP is increasing, but it increases at a decreasing rate. The total product of the variable input labor will increase at a decreasing rate. This is the second relationship. That is, whenever MEP decreases but positive, then TP increases at a decreasing rate. At this point, the total product curve reaches at its maximum, and whenever TP reaches at its maximum, MEP is 0. And beyond this point, the total product curve is declining, and whenever TP declines, you are asked to tell something about the patterns of the MEP beyond this point. So whenever TP declines, MEP is negative. So the four relationships between TP and MEP are: whenever MEP increases, TP increases at an increasing rate. Whenever MEP declines but positive, TP increases at a decreasing rate. Third, whenever TP reaches at its maximum, MEP is 0. And finally, whenever TP declines, MEP is always negative. Now, let's see the relationships between the average product of the variable input labor and the marginal product of the variable input labor. Starting from this point to this point, the marginal product of the variable input labor is above the average product of the variable input labor. Whenever MEP is above AP, then AP increases. This is the first relationship between AP and MEP. Whenever MP is above AP, AP increases. At this point, the average product of the variable input labor is at its maximum point. And whenever AP equals to MP, then the AP curve is at its maximum. And beyond this point, the average product of the variable input labor is above marginal product. And whenever AP is above MP, then AP decreases. So the three relationships between the AP and MP of the variable input labor are: whenever MP is above AP, AP increases. Whenever AP equals to MP, AP is at its maximum. And finally, whenever AP is above MP, then AP decreases. Now, let's see the stages of production. There are three stages of production called the first stage, the second stage, and the third stage. The first stage of production starts from the origin to the point where AP equals to the MP curve. The AP curve equals to the MP curve at this point. The second stage starts from the point where AP equals to MP, or AP is maximum to the point where MP is 0 or TP is maximum. And the third stage is whenever TP declines or MP is negative. In the first stage of production, the marginal product of the variable input labor is always above the average product of the variable input labor. Hence, the firm is advised to employ more variable inputs because the firm is getting more output from the employment of more variable inputs. In the third stage of production, the additional output that we get from additional employment of the variable input labor is negative. Hence, the firm is advised to reduce employment of the variable input labor. So, a rational producer is advised to produce in the second stage of production where AP is above MP but the MP is positive. This is about the relationships between TP and MP curves. This is the relationship between the AP and MP curves. And I told you the stages of production. The first stage starts from the origin to the point where AP is equal to MP to the point where AP is maximum. And in the first stage of production, MP is always above AP. The second stage starts from the point where AP equals to MP to the point where MP is equal to 0 or TP is maximum. This is a stage where a rational producer is advised to produce. And the third stage of production is whenever TP declines or the marginal product of the variable input labor is negative. Now let's see a law called the law of diminishing marginal returns, LDMR. It states that as we employ successive amount of the variable inputs over a fixed input, then the additional output that we get, additional employment of the variable input will eventually decline. This law in short tells us the marginal product of the variable input labor will always decline, but the law starts to operate after the MP curve is at its maximum. For example, if we have 2 hectares of land, producing weight on 2 hectares of land by one labor is good. If we employ another labor, it is very good. But if we employ 10,000 laborers on 2 hectares of land, then the additional output that we get from additional employment of the variable input labor will always decline. We will not get good output from the given combination of the inputs. Students, this is all about the first lesson of Unit 4. Stay safe, stay home. Thank you.